All right, Caitlin, this is the problem that I was not able to solve during our session. And I was kind of embarrassed about not being able to solve it, but then my father has a PhD in mathematics, and I called him about it. And he agrees this is a much too difficult a problem to be on an a high school AP calculus test, even advanced placement. It's ridiculously hard. And well, here, let's just get into it. You know what the question was. The line t is tangent to the graph of y is equal to e to the x at the point k e to the k. What is the positive value of k for which the y-intercept of t is 1/2? And yeah, it's a really difficult question, but we have to start somewhere. Well, we'll start with what we know. There is a line t. It is going to be a function of x. So we will call it, we're going to call it g of x. And it's a tangent line. What do we know about a tangent line? Well, it's a line, so it's going to be in the form mx plus v. It's going to be in slope y-intercept form, where the slope is equal to m, and then of course you have times x, and then plus b, which is where it intersects the y-axis, shown here. It intersects it at the point 1/2. I should have labeled that. This is the point 1, and this is 1/2. Okay. And this is the point k, and this is the point e to the k. All right. So yeah, we know this about t. We know it's going to be in this form. Well, we also know that there is this function y, which is also a function of x. We'll call that one f of x, like normal. And it's equal to e to the x. Okay, well, how can we go further? Well, we are given that the y-intercept of t is 1/2. All right. So what corresponds to the y-intercept? It's this value b. All right, so b is 1/2. So we've gone a little bit further. Okay. What do we know about the slope? Well, nothing yet, but we do definitely know a lot about the slope of this curve right here. Since this curve y is equal to e to the x, y prime, or the slope f prime of that function evaluated at x, is also equal to e to the x. Therefore, any point k, the tangent line to this curve right here, e to the x, at any point k is going to have a slope of e to the k, because this is e to the x. The slope along this curve at any point x is equal to e to the x. Therefore, the slope along this curve at any point k is equal to e to the k. Well, they intersect at the point k, e to the k. All right, so this point right here falls on this curve. Therefore, the slope of this must be e to the k, because it intersects right here at k, e to the k. So the slope of t has to be e to the k. I hope you understand why. This is the function e to the x. Any point along it, the slope is going to be e to the x. Any point k, right here, the slope is going to be e to the k. So we can replace this slope, m, with our known slope, which has to be e to the k. It's a very, very difficult problem. All right, so now we have this function. G of x is equal to e to the kx plus 1/2. All right, I'm going to write that again down here. So g of x is equal to e to the k x plus 1/2. Well, what else do we know about this function g of x, or t? We know that the point k, e to the k, falls on it. Therefore, we know that g of k has to equal e to the k. Okay? What does that mean? That means this function evaluated at the point k is equal to e to the k. That means that e to the k plus 1, e to the k, we know g of k is equal to e to the k. That means this function evaluated at the point k is equal to e to the k. So that means this function evaluated at e to the k, which is e to the k times k plus 1/2. I hope you would agree that that is this function evaluated at the point x is equal to k. We just replaced k with x. And that, what did we say that was equal to? It's equal to e to the k. G of k is equal to e to the k. All right, well, all right, now we have a function that's purely in terms of k, or an equality, I'm sorry, an equation that's purely in terms of k. And we are asked to find the positive value of k, all right, for which the y-intercept was 1/2, but we already took care of that part by this 1/2 right here. So if we solve this equation for k, we have found the exact answer to the problem, and then we just pick it from here. Well, that's not going to be possible because, well, let's go with this. Let's did I do that right? Yeah. G of k, which is this thing, is equal to e to the k. Okay. So let's subtract k e to the k from both sides of this equation. Minus k e to the k. All right, that's the same equation we just had. All right, let's factor out an e to the k. This is how you solve things. All right, so that means we have 1/2 is equal to e to the k times 1 minus k. All right, just factored out that e to the k. All right, in order to solve this, you need to know something called the Lambert W function, and that's not something you really learn even in like university level calculus. The Lambert W function is a very obscure function, and people just don't use it that much. And unless you are like really into math, you're not going to know what that is. So they can't expect you to be able to solve this for k algebraically. You couldn't be expected to do that. So the only way that you're going to be able to get the correct answer to this is by plugging them in and see which one gets you closer to 0.5. Right? Okay. So let's put this into a calculator and see what value of k makes this equation the closest to 1/2. That's the only way we're going to be able to do it. Okay. All right, let's plug in the first one. So e to the 0.405. Let's see what that gives us. E to the 0.405 times 1 minus 0.405. Nah, gives us like 0.9. Okay, so that's not it. Let's try 0.768. There we go. That one's extremely close to 0.5. In fact, it's 0.50006466408. So this is definitely the answer, B. And that's the only way you can solve that. You literally have to just plug in these values and see which one gets you closer. Yeah, that's the best solution I can come up with for you. I hope you can follow that. Like I said, this problem is really, really difficult for a high school calculus class. So if any of your classmates are able to solve this, you know, I give them major credit.